Hello and welcome to this practical walkthrough of how to apply what we learned in the last video and how to use tidy models to train a linear regression model, and even before that, how to just use base R but without doing anything from scratch, using built-in functions, how to train a linear regression model on a real data set. And in this case, we're going to be using the diamonds data set. So right before I start, let me just give you a caveat. This might get a little messy, it might get a little confusing because, at this level, there are so many ways to do so many different things and so many, options you have of training your model, of, selecting the variables you want to train on, so on and so forth. So a lot of this stuff, you might have questions as to why I did it one way and not the other and that kind of stuff. What I recommend for you is, first learn how to do it the way I'm showing you, but then experiment, right? Try different stuff. Go and research why another method, it doesn't work or does work, and just get your hands dirty. You've gotten up to here in the course, so you have quite a bit of knowledge on how to use R and the tidyverse and that kind of stuff. So, don't take what I'm doing as gospel, but use it as a base to start. Okay. I'm not going to really go into explaining too much of the simpler stuff that we should have already learned in the previous sections. So if you do ever have any questions as to why I did something a certain way using dplyr or something like that, go and review the other videos. So before we start, let's load some of the libraries that we might need. So I'm going to be using ggplot2 to visualize visualize the results. And so let's load that. We're going to definitely dplyr for wrangling the data. We're going to be using a package called core with 3 R's like this, which is a package that helps you visualize or view or calculate the correlation between different variables within a data set. So I'm going to be showing you how to do that. Remember, I mentioned this to you before briefly, but in every one of these sections, I'm going to be covering additional stuff related to machine learning that's not specific to that section, but that's specific to machine learning in general. And I'm going to use each section as an opportunity to cover another topic like that. So in this section, I'm going to be covering correlation. How would you calculate correlation, that kind of stuff. I don't have a separate section for it. I'm going to be including that in this video. Watch out for that. And then obviously we're going to be using our sample to create our training and testing data sets. And then we're going to be using recipes to perform our data processing. And finally, we need parsnip to do the actual model training and that kind of stuff. So let's go ahead and load those. So we don't have a package called core, so we have to install it and go ahead and install it. And then, let's get set up with the rest while that's installing. So we're going to be using the diamonds data set. If you remember, we did some exploratory data analysis on the diamonds data set. This has to finish loading or installing first. So let's just let that install. So the reason we're using the diamonds data set is because the diamonds data set gives us a lot of numerical variables, but specifically the price variable, right? The price of the diamond is a very good output variable to train a model for, right? It's a very useful model, right? To be able to predict the price of a diamond based on its different attributes and characteristics and that kind of stuff. And because price is a numeric or a continuous variable, it only makes sense to use a regression algorithm, right? This is a regression problem and not a classification problem, right? Because, price, it can be any value of a continuous spectrum of values or a continuous range of values. And so we're hoping that there is a relationship between clarity, depth, color, cut, caret, X, Y, Z, etc., and the price, so that when new diamonds come our way, and obviously we won't know the price of them, but we can measure their characteristics. We want to be able to predict with relative accuracy the price of that diamond. So this is a very good data set to, as a very good example of a regression problem. Okay, so we loaded core, our recipes, so install packages recipes. So now, before we use tidy models, I'm going to be using built-in, we use this actually in a previous section, the LM function. So this is a built-in function within R for training a linear regression model. And instead of training on all the different variables, I want to find the variables that have the highest correlation with the price. So I'm kind of use this as an example, as an excuse to use the core package, right? So before we actually get into tidy models, so we have to update. So these type of, especially since tidy models is a relatively new package, we're gonna have some problems, but don't worry about it. So it can all be handled. Let's just update this. So what we can do is we can just install generics, and that should do the trick. Let's go ahead and okay. So the reason I'm not cutting this part out of the video is because I want you guys to see like how to troubleshoot problems and that kind of stuff. Don't be scared. R is very helpful. It gives you the answer to everything you need. So in that case, this generics package was outdated, and it told us that it needed an updated version of it. So all we did was we had to, and the reason we encountered that issue is to save time. When RStudio prompted me to restart R when I was installing the recipes package, that would have actually updated the generics package, but to save time I said no, and so this didn't update, and so it caused a problem because it needed an updated version of this. So all I did was I just reinstalled it, and when it prompted me to restart R, I pressed yes. And so now we're just going to install the parsnip package, and then we should be done. So yeah, it is going to be a little bit more difficult to load these packages initially because most of them are still pretty new and that kind of stuff, and they're bigger packages and that kind of stuff, but you should not have a problem, and don't be afraid to troubleshoot and that kind of stuff. So now that we have these packages downloaded, let's go ahead and play around with the core package. So the diamonds data set, right, we're familiar with it, we don't need to go over it too much. Let's take the diamonds data set and let's select where the variables are not are not factors. So this keyword, you can go ahead and search and learn more about it. We covered this before. This helps to search through all the columns and run whatever function here on those columns, and whatever returns true, it selects it. So in this case, .x would be that particular column. So it would do this for every column. Again, this is not the place for deploy R, but so essentially here we're selecting all columns that are not factors. So essentially that would mean, because remember, if we skim diamonds, right, there are all the non-numeric columns are factors. So essentially we're picking all the non-factors, so we're picking all the numeric columns, and we can pipe this directly into the correlate function. Now the correlate function belongs to core, so I'm gonna write it like this just so you know where it comes from, but we could have just written correlate because we loaded core into our environment. So this essentially gives us, you can ignore these warnings, this gives you details as to how the correlation was calculated and that kind of stuff. Ignore this, but this is what we want. So this basically gives us a data frame of all the variables by all the variables and the correlation between them. So for example, the caret. So what is the correlation of each of the other variables to this variable? So for example, depth has a correlation of 0.0282241 to caret, whereas table has a higher correlation, an order of magnitude higher, to caret, where price has an even higher correlation. This means that the higher the price is, the higher caret is. So caret and price seem to be very highly linked, very highly correlated. Same thing with x, right, y, and z. And likewise, you can go through each variable, right? You can see that, in fact, the correlation of table to depth is negative. So this means that as table increases, depth decreases, but the strength of this correlation, this relationship, is not that high. So there is an inverse correlation, but it's not very well defined. So whenever it's negative, it means it's inverse. That means as one increases, the other decreases. And the lower the number, that means the weaker the link or weaker the relationship between the variable, and the higher the number, the closer it is to 1, the higher the relationship. So you can almost directly describe the behavior of the other variable using that variable. So core basically provides us with all functions that have to do with this table. So it allows us to beautify this table to make it cleaner. So we can use another function from core called fashion, and it's the same data table, but this time it cleaned it up. It rounded everything to the nearest hundredths, and it just made everything cleaner and easier to understand. And then we can also create a network plot. So the core packages provides us with a bunch of functions just to help us play around with these correlation values. So instead of fashion, we can use network plot, and there we go. It plots a net. So these variables appear to be most highly correlated with one another. There are correlations between the other variables, but they're so low and so minimal, even appear, right? They're so close to a zero correlation. So zero correlation means that there's no relationship between two variables. Like one increasing does not affect the other increasing or decreasing. If there had been red lines, that would have meant that there are very high inverse correlations, which means that as one variable increases, so for example, if there was a red line between depth and caret, that would mean that as depth increases, caret would decrease, or as caret increases, depth will decrease. But from what we can see here is that the highest correlation seems to be between caret and like z and that kind of stuff, and y, and in general is between these 5 variables. So for our sake, just for the sake of this example, so we already decided that we want to predict the price, right? Because that's what makes the most sense. You'll get a diamond, and you'll be able to measure the caret, the x and the y and the z and all of that, but you want to be able to predict the price, because a diamond doesn't come with its price on it, right? If you're a jeweler or you're in the diamond industry, when you get the diamond from the mine, it doesn't have the price engraved on it. So it would make most sense to predict the price of new diamonds and not the caret or anything else. So let's select the variables that are the most correlated with the price variable, and let's just select a threshold of 0.5. So like if there's a 50% correlation, there's more than a 50% correlation between price and another variable, we want to select that variable. Otherwise, we want to discard the rest of the variable. So let's take diamonds. We want to select where the variable is not a factor, and then we want to build the correlation data frame, and then we can focus. So let's print this. Remember, this is what we have. We can use a function from core again called focus, and this will give us a single column. So we want to focus on the price, so we don't care about this. So we only care about the correlation of price to the other variables and not any of the other variables to any of the other variables. So we want to focus on price, so that just gives us the correlation of price to caret, depth, table, x, y, z, and you can see that they all have different correlations. So the strongest appears to be caret. We can do fashion just so it's easier to read. So the strongest appears to be caret, and then there appears to be a very weak yet inverse correlation between price and depth, and then there's a very weak correlation between price and table, and then there is quite a significant correlation between the X, Y, Z variables and price. So this means that we should be able to predict price by knowing the caret X, Y, and Z of the diamond. Now, we could here pick, we could by looking at this and interpreting these results visually, could decide, we can go in and manually pick caret X, Y, and Z, but we want to build a workflow that we can easily adapt, right? What if a new column is added to the diamonds data set, and then we'll have to go in and do everything manually again. We want to make it as automated as possible and requiring as little human intervention as possible. So what we can do now is we can use dplyr to arrange our sort, right, by increasing price. Wait, just 1 second. So this is price. So let's remove this. So there we go. So from highest correlation to lowest correlation. Now this is called price just because that's the outcome variable predicting, but this is actually correlation, right? These are correlation values. These are not actual price values. Now we want to filter for where price is greater than 0.5, which means that the correlation is higher than 50%. So we're left with caret X, Y, and Z, and then we can actually extract this column because these are the names of the columns that we want. So we can use pull from dplyr to extract the term column. And so now we're left with the names of the columns or the names of the variables within the diamonds data set that have correlations of greater than 50% to the price or the outcome variable. Okay, so let's save this into high correlation variables, and we can, so if we run this, right, we get these. Now from the diamonds data set, just those columns. So select high core variables, and we want to select the price, right? So there we go. We selected caret X, Y, Z, and price. So what essentially this allowed us to do is, now if a new row gets, or a new column gets added to the diamonds data set, right? And let's assume that that column has a correlation to the price column that is higher than 50%. So now if we rerun this whole notebook, right, by the time we get down to here, that column will be included in here because everything is automated, right? There's no manual intervention. We didn't look at the results and then decide to manually select these columns. So if there is a new column added to the diamonds data set that has a higher correlation than 50% to the price column, it'll show up here automatically when we rerun the notebook. So try and do that as much as possible to make your code as dynamic as possible and abstract out any of the decision making so that it can easily adapt to new or to changes in inputs and data and that kind of stuff.